So we're going to practice using simple gear trains to find missing variables. So the first question is asking, is this gear train gaining torque or speed? And explain how you know. So the input is at gear A and the output is at gear B. And we're starting with a smaller gear and we're going to a larger gear. So therefore we're gaining torque because we're going from small to big. Question number 2 is asking us, what is the gear ratio of this gear train? So we need to find the gear ratio, but we have 4 different equations that we can choose from. So we're going to use the information we're given about this, and we're given the information in the number of teeth. So the letter that we use to represent the variable number of teeth is n. So we're going to do n out over n in. And these formulas you can find in your notes or on the formula sheet on page 6. So I'm going to take the number of teeth out is 30 divided by the number of teeth in, which is 10. So my gear ratio is 3:1. So I'm going to write it up here just so I've got that to remember. And what I'm going to do is I'm going to make a little table here to keep my information together. So I've got my input, which is gear A, and I've got my output, which is gear B. And I know the number of teeth for this system, so I know in has 10, out has 30. Next, for question number 3, it's asking us to find if gear B has a diameter. So I'm going to be finding diameter. I know gear B has a diameter of 24 inches. So that's my out. I've got 24 inches. So I need to calculate my formula using gear ratio is the diameter of the output divided by the diameter of the input. I know my gear ratio already. I'm not solving for that. My missing information is the input diameter. So my gear ratio is 3. So I'm going to plug that in. The diameter of my output is 24 inches. The diameter of my input is unknown. So I need to find my missing variable. So what I'm going to do is I need to get this variable out of the bottom of this fraction. So I'm going to do that by multiplying it up. So I've got 3 diameter equals 24. Then to get diameter by itself, I need to divide both sides by 3. So I'm left with a diameter of 8 inches. Question number 4 says we have 20 foot-pounds of torque. So I'm going to come up here, I'm going to add torque. I know I have 20 foot-pounds of torque on gear A. Gear A is my input, so I'm going to put 20 foot-pounds of torque. And then I'm going to use my gear ratio formula. I know gear ratio is torque out divided by torque in. My missing information is the torque out. I know my gear ratio is 3. I know my torque out is missing. And I know my torque in is 20 foot-pounds. So to get my torque out by itself, I have to multiply both sides by 20. So I'm going to do 3 times 20 to get my torque out. So my torque is 60 foot-pounds. And the last question, question number 5, says we have gear B moving at 25 miles an hour. How fast? So this keyword fast tells me that I'm going to be finding the speed. Speed is represented by a lowercase omega. So I know gear B, 25 miles an hour. B is my output. So I've got 25 miles per hour. I know my gear ratio formula is gear ratio equals speed of the input divided by speed of the output. Alright guys, so my last video stopped recording. I'm sorry about that, so I'm going to explain what happened. So we were finding the gear ratio. So we know our gear ratio formula is the speed of the input divided by the speed of the output. So plugging in the information I know my gear ratio is 3. So I'm going to plug in 3 for my gear ratio. I don't know my input, but I know the output is 25 miles an hour. So in order to get speed in by itself, I have to multiply 25 miles an hour onto the other side of the equal sign. So I'm going to do 3 times 25 equals my speed in. So if I multiply 3 times 25, I get my 75 miles an hour, and I recorded it up in my data table.